Okay, so for an isolated system, energy can be converted into different forms, and we discussed that a little bit earlier, right? It doesn't matter what the form is, right? It could be sound, heat, uh, potential, kinetic, right? Just all these different kinds of energies that we've discussed, right? But cannot be created or destroyed, okay? So that just basically means what you start with, you have to end with when you add them all up, right? And so for a car accident, you might have like kinetic being turned into sound and heat, right? But all the energy is still accounted for. It just got released into different forms, right? And so the law of conservation of energy is an example of a conservation law that applies to an isolated system, right? Which is a system of particles that is completely isolated from the outside influence. Okay, so I would say for the most part of these questions, I think we're going to probably ignore the fact that friction's acting on things, right? So they're going to be frictionless tracks, at least for your context, or like there's no wind resistance, right? Because friction creates heat. And we're not going to get into how to incorporate the heat loss into this particular equation. Okay, but the main goal here, or like the big idea, is the total energy, and this is what's going to go on this line. The total energy of the system remains constant with no energy flowing into or out of the system. Okay. And so all we've done in step 1 here is we've taken what this says, so the total amount of energy, like the words, we're taking the words and we're putting them into like a mathematical statement, right? And so for our purposes, you could have any number of these things. You could have EH, you could have whatever, right? You could keep going with the amount of energies, right? And now I'm thinking about it, I remember actually doing in my last year at university, I took like a hydro shed, like my degree's in environmental science. And we looked at like a watershed, and we looked at like the flow of water in that system, and we looked at things like how much loss, like how much water are we losing due to latent heat, or like the movement of the water, right? Or like ground fluxes and things like that. We had a big long energy statement, just like this, just like what we're talking about. It's just more and more complicated to build something like this, right? The idea is still there, right? You're just trying to account for as much of the energy as you possibly can so that you can get a big picture, right? What we're going to say is like, let's just treat this as an isolated system. We're going to ignore things like friction and wind resistance that are ultimately going to cause losses to heat to the surroundings, right? So we're just looking at the two types of energy that we've dealt with, right? We've dealt with gravitational potential energy, and we've dealt with kinetic energy, right? And we know that the initial amount of energy has to be equal to the final amount of energy in an isolated system. Okay, so what does this look like then? Well, for our purposes, we've only dealt with two kinds of energy. We're going to say, okay, well, Eg, right? We could say Eg plus Ek, right? So I could say Eg plus Ek, and we put little i's on there because for the initials, has to equal Eg F plus Ek F, right? So when I add up the gravitational potential energy with the kinetic energy initially, that has to equal the gravitational energy and the kinetic energy after. Okay, so there has to be some, these two numbers can be different. They don't have to be the same numbers, obviously, because then that wouldn't be interesting, right? So if this increases, then this has to decrease, right? And vice versa. Okay. So we can create a statement around this, and this is the statement that you're going to use for these questions, right? Well, how did we define gravitational potential energy? Well, we defined that as mgh. And we'll put a little, like, I don't know, a 1 or an I there, the initial height. And then I'm going to add any kinetic energy that the object had initially. So plus 1/2 mvi squared, right? And that has to equal the gravitational potential energy final, right? So mgh final plus 1/2 mv final squared. That's it, guys. That's for the purposes of your course, and even in the grade 12 course. It doesn't get any more complicated than that, really. This is what we're looking at. And this is the equation that you're going to use for all of these questions, right? So when I come down and look at something like this, I always make note of, like, initial velocities, final velocities, initial heights, final heights, right? And those are all the information. I always set the question up in two, like an initial stage and then a final stage, right? Does anybody have any questions? So if we took a look at example 1 here, a basketball player makes a free throw shot at the basket. The basketball leaves the player's hand at 7.2 meters per second from a height of 2.21 meters above the floor. Okay, that seems like it's just described all the initial information. We want to determine the speed of the basketball as it goes through the hoop 3.05 meters above the floor. Okay, so let's write our general argument, the one I have highlighted, right? And you can use 1s and 2s. I almost prefer you'll see with the 2s. Sometimes when you do this, they get a little bit messy. The other thing I used to see too in grade 12, and I don't think in math you guys wouldn't have seen this unless you're in the 4Us. If you had something like we have V, you could just leave it a V, and then I'll denote this V1 and V2 here for a second. I just want to make a clarification because you'll see if you guys read the textbook or like you go online and look at things, there are subtle differences in the way that they denote variables. Okay, so I'll write V1, V2. You could see VI, VF. You could also see V and V prime. This is the one that's I just want to bring your attention to. If you go looking for other questions or solutions to things, or like you're reading the textbook or something, right? V prime indicates afterwards. The problem with V prime is when I write, and I don't really like V prime for this reason. If I were to write half mv prime squared, this looks like a 12. I don't like it, right? Inevitably, you're going to see it. I just want you guys to see that that's not a 12. And it's hard to denote differently. Okay, so for our purposes, what I'll try to do is spend my time writing things like this, okay? V1 and VI, or V2 and VF, just like what we've been doing with, I don't know, any other velocities, okay? Kinematics or whatever. Okay, does anybody have any questions? I'm just going to run through this question now. Okay, but I'm going to use these two. I just wanted to bring your attention to that V prime thing because it gets messy. It's fast to write, but it creates funny looking equations. 12s and okay. So here's what we got. I'm just going to write out this equation up here. I'm going to go mgh1 plus half mv1 squared is equal to mgh2 plus half mv2 squared. Now, we are talking about the mass of the basketball. Okay, so the mass doesn't change across this entire equation. So what you could do, I'll show you the math of this, but you'll notice in two terms, you have m twice, right? So we could just go m, and we're going to have gh1 plus half v1 squared. And that's going to be equal to m gh2 plus half v squared, v2 squared. And if you were to divide both sides by m, it's independent of the mass. The mass of the basketball doesn't matter. And that is exactly why in this question, it did not specify what it was, because it didn't matter. Okay? I just wanted to show you that for the validity of what's going on, so I didn't just go like this and everybody go freak out. Cancel, 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 cancel. Okay, this line here shows you the math of that. Okay? So if I don't give you something, if you guys ever read a question, you're like, oh, I'm missing something. That should be a clue, right? And that's why I write down all my knowns and unknowns, right? Because if I write that down and I go, oh, m's missing, now I'm looking for it in the math for it to cancel or be able to factor it out, right? So what are we doing now? Okay, well, I'm just going to try and like, what's the thing we're identifying? Well, I'm looking for V2. So why don't I just isolate for V2 algebraically and then plug in all my numbers at the end, right? So let's do that. So I have GH1 plus half. My screen flickered. I thought I saw somebody type something, but it's okay. V1 squared has to equal GH2 plus half V2 squared. Now, it honestly doesn't, for the grade 11s, it honestly doesn't matter to me if you guys like just want to plug in your numbers and do your thing. I don't care. But remember what I tried to illustrate to you guys. Like, I just want to, algebra should be your friend, and we should be able to like work with these things, right? So I don't care if you plug in the numbers. It doesn't bother me. What I'm trying to do is save you guys time and try to eliminate typing in like a calculator error or rounding error or anything like that. Okay. Because if you do get to university and your answer could, there was a couple instances on the first summative where some of your answers were like, I don't know, 2 or 3 meters per second off, right? I gave you the marks, but some of that's rounding, right? And it's a difference in the solution. Well, you get to university, I don't know, they could be really mean and put a whole bunch of answers that are 2 or 3 meters per second off. You don't know which one's which, right? This is like, that happened to me. There were tons of instances where like in first year where they're trying to get the people that they not that they want to get through, but they can like cut it, right? That's what they do. They put answers that are close or they purposely do questions wrong and put that answer in the multiple choice answers, right? So all I'm trying to illustrate here is like, let's try to eliminate all the factors of error, okay, and try to work with problems in algebra, right? So let's go through this. All I need to do is get V2 by itself. That's all I'm after, right? And so I'm just going to do a little bit of math that you're going to do anyway with the numbers, right? It's just there's letters there anyway. So what you can do is take this term and move it to the other side by subtraction, right? Or create a zero pair by minus GH2. And what you do to one side, you have to do to the other. So GH1 plus 1/2 V1 squared minus GH2 has to equal 1/2 V2 squared. All right, well, let's multiply both sides by 2. The 2 is going to cancel with that 2 now. What you do to one side, you have to do to the other. Right? And then, we're almost done. You can just square root both sides. Deal with this squared. And now you have V2 by itself. V2, square root. So what do you get? V2 is equal to the square root of 2GH1 plus 1/2 of V, oh, there's brackets, be careful, V1 squared minus GH2. Okay? Did we have any problems with what I did there? Again, like you guys could have typed in the numbers up here. All I'm saying is like, you're gonna, I learned in university to do this, all this work, right? Dealing with things in algebra, right? Not the best time to be doing that is from my experience. So let's just, even if you play around with like some of the homework questions, trying to do questions like that, that's all that matters. Okay. So all you got to do is plug in all the stuff. You know all the stuff there now, right? V2 will be equal to 2 times 9.8 times H1, which would have been 2.21. That's from right here. Plus V1 squared, which would have been 7.2 squared, and then you're going to multiply that by a half, which is the same thing as dividing by 2, minus 9.8 times H2 would have been 3.05. And all of that is square rooted. Now the nice thing about this is you can just go into your calculator, you open up 2 brackets, you type this whole thing verbatim. There's none of this like rounding, and you just go to your calculator. If you have a scientific calculator, you go 2 bracket 9.8 bracket 2.21 bracket plus. You just type this all in verbatim, and at the very end you hit square root answer, and you should get 5.9 meters per second. Like I'm looking at my grade 12 solution there, and it's filled with numbers. But each one of them is like 7.2, 2.21, 3.05. You know what I mean? Like the 3.05 isn't rounded, but you guys get the point, right? You start multiplying like 9.8 times 2.21. That's going to be 25.9. What rounding did I do there? Well, I have no idea. Right? Whereas I can get to the final answer. This might even be a little bit off because I've done this a different way. You guys can check that. Okay, does anybody have any problems, questions, concerns? Really, the big point here is, can we set up these? It's almost the same thing every single time. With the exception of sometimes you might get lucky and V1 would be 0. And so you wouldn't have any initial kinetic energy. You would only have, like if you had, like we're going to see in the next question, something like a roller coaster, all potential, and you release it. So there's no kinetic initially. So you just get in the habit of always writing these statements like that, you know, like the conservation of energy law. You write that out, and then you analyze the question. Now, can anybody, out of curiosity, so here's a roller coaster. This is what I was talking about yesterday. 100-kilogram roller coaster with its passengers starts from rest at point A on a frictionless track, whose profile is shown in the diagram. Can anybody identify where, so either A, B, C, D, or E, the roller coaster is going to have the highest speed or maximum speed for part A? Can anybody identify where that's going to be? Okay, Jagger says D. Does anybody disagree with Jagger? Okay, I would tend to agree. I think the argument there, Jagger, from the tracks that we saw, those marbles had the most amount of kinetic energy at the low points because all of that potential, or a lot of it, got converted from potential energy to kinetic at the low points, right? And so kinetic energy is purely based on the velocity of the object, right? 1/2 mv squared. The v is the controlling factor here, right? So if all its potential up here gets converted to kinetic down here, that's going to be the maximum speed, and that's the point at which we care about right now. Okay? So, maximum speed occurs at. Okay, what I'll do this question, guys, and then I'll do a video for example 3 and I'll post it. Okay, so we'll just do this one up, and then you guys can watch the other one after. Okay, I just gotta pull up my solution here so it goes fast. So I have to type in my calculator or anything. Okay, now I think the argument that's been made here initially is, I'm just gonna write out the conservation of energy here. mg h1 plus half mv1 squared has to equal mg2 mgh2, sorry, getting ahead of myself, plus half mv2 squared. Okay, now let's just take a look here. I think there's been an assumption made, and I think the assumption is going to be it can never be 0, but I think for the simplicity of this question, 30 centimeters difference, you're almost assuming that this thing's almost not moving there. Okay, that's the assumption for this particular question. Okay, and so initially, and if you guys have ever been on a roller coaster, you'd probably know that it just gets the just enough, and then it goes down again, right? So we're just going to assume that this VI is 0 because I don't know it, right? And it's almost 0. I think what you guys could do, it's not that it's 0, but it's very close to 0. And that assumption allows us, you could figure it out. You could go, okay, all potential turns into kinetic, turns into how much potential and how much kinetic. You'll know like the energy total there, right? You can figure out exactly what the speed is there, but for the interest of this question and time, we're just going to assume that initially it's almost 0. But the velocity would be very, very small, okay? So what are you left with? Well, I'm left with mgh1 has to equal mgh2 plus half mv2 squared. Okay, and what am I interested in again? I'm interested in v2. Okay, this time v2 just looks a little bit different because I don't have any kinetic energy initially, or very minimal amounts. And again, you could find that out. Okay, just for this particular question, I'm just oversimplifying. Okay, maybe to a fault for this question, but I just want to get you guys through like this question. Okay, so let's just do a little bit of isolation. We could get mgh1 minus mgh2 multiplied by 2 square rooted. So you may have any problems with what I did there? Oh, I do. That would have been equal to mv2 squared. That was close. Or mv2. Divide both sides by m. I forgot about that. Okay. That's equal to v2. Okay, so now you just type in your numbers. And really, again, mass is irrelevant. So it's divided by both terms. Or both terms are divided by m. So you just get, we can go v2 is equal to 2 times 9.8 times h1, which would be 9.2, minus, and this is in square brackets or round brackets. I suppose that's the only downfall to doing math like this. You gotta really be careful with the brackets, otherwise you're gonna multiply the front one by 2, but not the second one. The whole thing needs to be multiplied by 2. So just be careful with your brackets, that's all. Okay. H2, we're going to use 0.5. And that all has to be square rooted. Okay? And divided by m. Oh no, m's gone. All right, so V2 should equal for this question after you guys do the math. And again, I'm looking at my solution, I got like 90.2 for this one and 4.9 for that. How accurate is that? I don't know. How far off? It could really be like 90 point, I don't know, 1.15, right? It could be a little bit off. That's all I'm trying to illustrate is the rounding error, okay? Now let's have a look at with what speed does a roller coaster have to like arrive at point E, right? Well, let's have a look. Still an energy argument, right? It's going to have potential like right here, we're still going to have potential and kinetic, right? Down here, there's a little bit of potential and a little bit of kinetic, but we know most of the information now, right? So I would just write, okay, well, mgh1 plus half mv1 squared has to equal mgh2 plus half 2 squared. We don't always have to be looking for V2, but we are in this particular question. Remember, this is all stuff to deal with point E, and this is all stuff to deal with point D. Okay? But again, the math doesn't matter. Get rid of it, because it's in all 4 terms across the entire equation. And we can just do the math now. Well, initially, my potential energy would have been the gravity constant multiplied by the height of which we are off the ground, which is 0.5. So we just keep doing the same isolation, unfortunately. But we can look at, V2. There'd be other questions that you guys are going to see where you're not solving for V2. You want to know what V1 is, or like what is the mass of the coaster, or like the roller coaster or something, right? So we could say, okay, well, let's just isolate for V2 again. Well, it's just GH1 plus half V1 squared minus GH2 all times 2 and square rooted. Right? And you guys are just going to plug in all the same numbers again, right? And you're going to find that V2 should equal the 8.6. Sorry. Again, should be 0.8, right? But I'm doing my grade 12 non-algebra stuff, and I'm getting 8.6 meters per second, right? That's what I'm talking about. It's a perfect example, right? It's not a huge difference, but you can see it. It's a difference. Okay? Again, all I did there was plug in all the numbers from the question. Okay, where H2 is 5.5. And we now know what the velocity was there. That's from the last question, 13.1. That would have gone in here. And if I'm ever saying too much, just let me know, okay? Because I don't know. I'm just doing this for everybody's benefit. So the V2 from point D turned into the V1, right, for the other part of this question.